Next up, we look at the graphical effect of dilation factors. Suppose I have a function or a relation. I apply dilations a, b in the xy direction. What are the effects? Well, let's take a look at the horizontal dilations first. If a greater than 1, then it's a horizontal stretch. If a is smaller than 1, but bigger than 0, it's a squeeze. If a is 1, then there's no change. And if a is negative, there's going to be a reflection plus some sort of dilation. Similarly, if b is bigger than 1, it's a vertical stretch, where this is the transform. If b is smaller than 1, but greater than 0, we get a vertical compression. Now, if b is smaller than 0, we get some sort of reflection with dilation. So let's look at this on the CAS calculator. First of all, I'm going to define some function, f(x) equal to, let's say, x cubed. To define a function, you need to use this symbol with the equal symbol. Now it's saying then, so I've defined my function. We can plot the graph of f. It looks something like this. Now let's suppose we want to add in the dilation in the horizontal axis by factor of a. Then we need to change the argument from x to x upon a. Now we get a slider. You see, currently the value of a is 1, so nothing changed. If I increase it, I will be getting a stretched version of f, and the stretch is away from y. Now, if I make a smaller, say 0.5, then I'll get a narrower version of f. And if a is negative, I'll get a reflected version of f. Now, let's remove a and see what's the effect of a dilation factor b in the y-axis. Higher values of b will get a stretched version of f in the y direction, such that the points are further away from x-axis. Let's see that in action. Obviously, it's narrower because now the points are further away from x. If I make my value of b smaller than 1, say 0.5, we'll get a stretched version of f, but stretched toward the horizontal axis. Of course, if I make it negative, I get a reflection. It's a simple reflection if the factor is just -1. But if it's -2, for example, it's going to be a reflection plus a stretch. That's the way to understand it. Of course, I can have both dilations in x and y combined. So let's add a back in. Now, obviously, they will just combine to make a total effect. But this effect is still understandable as a combination of transformations.